So students tend to love this one as well. How much of a 20% alcohol mixture and how much of a 65% alcohol mixture is needed to obtain 270 ounces of a 60% alcohol solution? And yes, this one we are definitely going to set up a system of equations. And first, we just need to understand the two things we're mixing. So first, we're going to start with a 20% mixture, and then we got a 65% mixture right here. And what we want to do is know that when we add these two together, what we want to end up with is a 60% solution, right? Okay, well, there's two ways to look at this, and they've given us two quantities to look at, right? You have the ounces, so that should be its own equation, and then you have the solution strength, I guess. So I guess I'm just going to put strength. Strength. There we go. I'm probably not using proper terminology there, but also I don't care, all right? In terms of ounces, here's what we got. We got 20% alcohol mixture, 65% alcohol mixture. We don't know how many ounces there is for each of these, so I can apply variables for these right now. So I could say right now, 20% is going to be my X, 65% is going to be my Y, and I know if I add those 2 ounces together, it did give me the mixture of those at 270 ounces, okay? So in terms of ounces, X plus Y should be 270, and of course there's lots of different values that add up to 270, but we're looking for something specific right here, and that's where the second equation comes in. I need it to match the strength to match the number of ounces. So first up, you have a 20% mixture, and the 20% as a decimal is going to be 0.20 or 0.2, and the Y, which is my 65%, is 0.65. Okay, now this would be 20% of an ounce, but we don't know how many ounces there's going to be, so we're just going to multiply it by X. And for the 65%, of course, we would multiply that by Y. If we add these together, notice it's a strength which is based on volume as well. So we have a 60% alcohol solution, but we do need to multiply that by 270 ounces, okay? And 0.60 times 270, yeah, just pull out your calculator and do that. That's what I'm doing. 0.60 times 270, enter, and this tells me it's 160. So my new equation here, let's see if I can do this. I have this kind of an equation, and if I wanted to look at the other one, of course, I would have an X plus Y equals 270. And the way these equations have set up, it's going to be a lot easier for me to use elimination for this. Now that I can get these numbers to match the 1, but I think it's going to be a lot easier to multiply the 1 coefficients by either 0.20 or 0.65. I just got to multiply them by their opposites, right? So that means that this first equation, I'm not actually going to change it right now. So I'm just going to move this over because I'm not going to change it. But the second equation, I am going to multiply it. You know what? Let's go ahead and get rid of the x's, all right? So I'm going to multiply this by a negative 0.20. Again, I want the coefficients to match, but I want them to be opposites. So what does this give me? Well, I'm going to have a negative 0.20x. And now I'm going to be subtracting 0.20y. And this would equal, now again, I go to my calculator and I do negative 0.20 times 270, and that gives me a negative 54. And with this much, I can now eliminate the x's because they're going to zero out. Then, for my y's, I've got 0.65 minus 0.2, which is going to be 0.45, and that's going to equal 160 minus 54, which is 106. Now this allows us to solve for y, and only y, which is the 65% solution. It's how much 65% solution there is. And of course, solving for this one, not too bad. All we got to do is divide both sides by 0.45. And what this does is it gives us a coefficient of y that's 1, Y then equals, again, just going to the calculator, 106 divided by 0.45 is 235, and it's 0.5 repeating. I'm just gonna round this to 0.6 on this one. And of course, don't forget your label here in ounces. Now you'll wanna be careful because, like I said, this only gives us a 65% solution, and a lot of students, what will happen is they stop right there and they say, well, that's it for me, I'm good, especially on exams. And that breaks my heart because there's no need to stop right there. Just remember, you have 270 total ounces, and we just found that of the 65% solution, there's 235.6 ounces. To solve for your X, all you gotta do is subtract these out. And again, if you need to use the calculator, I'm just gonna type this in just to make sure I don't make any errors, but that's gonna be 34.4 ounces. And that would be the 20% solution. Okay, so we had two conditions. You got 34.4 plus 235.6, right? That's our first condition in ounces. And will that give me the 270 ounces that we require? And again, I just go to my calculator and type this in. Yes, it does. So why is that important? Because it checks off the first equation. What we want to do now is check off the second equation, and I'll just, we've already done that calculation for 160 right there. So again, what am I doing? I'm doing 0.2 times 34.4, 0.2 times 34.4 in my calculator, plus 0.65 times the y now, not this y, but this y that we know it is, 235.6, or that we think it is. And when I push enter, what am I expecting to see? I'm expecting to see 160. Now I got 160.02 because remember, we rounded down here. So it is a little bit higher, but it's going to work. We now can see that we have in fact found the solutions. We have 34.4 ounces of the 20 ounce at the 20% solution and 235.6 ounces of the 65% solution. Again, we met both conditions that they gave us, so this one is complete.